Hey there, today's video is all about the GitLab RAG chatbot, what it is, how its code works, and why it's actually a game changer. But before we go into those technical stuff and details, remember this scenario when you asked a question to ChatGPT or Gemini or any of those large LLMs and it replied with an answer that sounded super confident at first, but later turned out to be completely irrelevant or a fact that isn't even real. Yeah, that's what we call as hallucination. And while it might be just funny when you ask about casual topics, meanwhile in fields like businesses, medical, or law, a wrong answer could cost real money and severe consequences. So, how do we fix that? Enters RAG, retrieval augmented generation. Think of it this way: instead of your AI trying to form an answer on its own memory, whatever it remembers, you instead make a vector storage of all your company's data, which is a knowledge vault, including of all documents, database, reports, spreadsheets, and all. Now, whenever you ask a question, the system first searches this vault, pulls out the most relevant information, and then feeds the context to that AI. The result? Responses that are not just fluent, but also grounded, accurate, and tailored to your data. No more random guessing, no more hallucination, and in short, RAG transforms your AI into a sharp, reliable assistant that always has the right context. Basically, a smarter and relevant assistant that actually knows your business. Alright, now with that being said, let's understand how the RAG pipeline really works. Don't worry, it's way simpler than it sounds, and honestly, way more powerful than you might expect. Let's walk it through step by step. I want you to take a look at this diagram. The phase 1 focuses on data preparation, while the phase 2 is data retrieval and generation. Now, it all starts with your document, report, article, manuals, and spreadsheets, everything you have as a data. And then, but instead of feeding the whole thing in at once, we break them into smaller, bite-sized chunk. Think of it like slicing a big book into chapters or paragraphs. Next, each chunk gets translated into a numerical form using an embedding model. Basically, we are turning text into vector mathematical fingerprints the AI can understand. This is like giving your data a universal language. And once everything is vectorized, we store it in a vector database. Imagine a lightning fast, super organized library where each piece of knowledge has its exact place. Now, phase 2 is data retrieval and generation. Now, let's say you ask a question to the chatbot. That's when the real magic kicks in. First, your query is also vectorized, turned into the same mathematical format as the stored data. Now, that way, your question also speaks the same language as the database. The system then dives into the vector database and instantly pulls out the top key chunks. Basically, the most relevant slice of information that is matching with the user query. Instead of searching through everything, it zooms in on just the piece that matter most. Now, those chunks are passed to the LLM, which uses them as a context to craft a response. The result? A clear, accurate, and context-aware answer, grounded in real data, not just guesses. Now, why this is a game changer? Here's the beauty of it. RAG just doesn't make up answers. It retrieves the right info, then combines it with the LLM's power to generate something tailored, precise, and reliable. In simpler terms, it's like having a super sharp context aware assistant who already knows exactly where to look and how to explain back to you. Fast, accurate, and always on point. Alright, now let's move from theory into practice and see how this diagram translates into actual code. Don't worry, the technical part is going to be much simpler than it might sound. In this case, we are building a RAG bot specifically for GitLab. As you know, GitLab is a web-based, all-in-one DevOps platform built around Git. And just like we discussed earlier, the RAG pipeline always starts with data. For our project, the data sources are two important assets from GitLab itself: the GitLab direction and the GitLab handbook. Now you might be wondering, what exactly are these? Let me clarify. The GitLab direction page outlines GitLab's strategic roadmap. It focuses on features that are upcoming in future, priorities, and long-term product vision that GitLab has. On the other hand, the GitLab handbook serves as a company's internal knowledge base. It documents how GitLab operates as an organization, including the product deployments, the guidelines, workflows, and the culture. Now, bringing these two sources together, we are basically powering a unified knowledge base, one that captures GitLab long-term vision as well as the internal practices that shapes how the product is built. The combination, it gives our RAG chatbot to deliver answers that are not only accurate but also balanced with both context of strategy and technical insights. Alright, here we have our first file in the GitLab direction, which basically is named as extract GitLab direction.py. What we are essentially doing here is we are extracting the GitLab direction data from this URL of GitLab direction. We have imported the modules as import request. The import request library, a simple and popular HTTP client for Python used to perform HTTP GET POST requests. And then from BS4, we are importing Beautiful Soap. Beautiful Soap actually converts the raw HTML and XML into readable format, essentially giving us a beautiful readable text file. And then we are importing the OS, which is a standard Python module for creating directories and handling path operation in our code. And now here, we basically fetch all the data from the GitLab direction and then we save it in the output file named as direction_clean.txt. Now we make sure that the directory we are saving the data in exists, or if it doesn't, we just make a directory. Now we have written a clean HTML function which basically uses the Beautiful Soap to convert the raw HTML and XML data into readable format. Now we use the request in the response to get the data from this URL, and then we call clean HTML function on that data. And by using file handling operation, we save that data at the specified output file, which is just present here. Now we have a enhance.py Python script, which work is to combine these two files. One is a raw data of GitLab direction and one is the clean data, and finally produce a polished direction final.txt file. Now the script starts with importing the path module. The path module essentially helps us with handling the operation related to directories where our files are present at. Then we import the regular expression module from Python, which is used to clean the data by normalizing white spaces, removing unwanted phrases like edit this page or contact us, also stripping out the bullet points. Then we specify the output path. If it doesn't exist, we make sure we create one. Now we have defined a function named as clean paragraph. Here we are using regular expression which we just imported above here to normalize the white spaces and clean the bullet points. This function takes a block of text and split it into paragraphs whenever it finds a blank line. Each paragraph is passed through clean paragraph function to remove unnecessary text. Very short paragraph under 50 characters are ignored since they are usually noise. And finally, what we are essentially doing is we are basically loading the file1 data into the text1 variable and the file2 data in the text2 variable, and then we are calling the getCleanParagraph function on them. After the processing and cleaning of these files are done, we are storing them in a set, and later we are using file handling function to write the data at the output file which is specified over here, named as directionFinal.txt, which is essentially located here. Alright, now with that being said, the direction data acquisition part is concluded here. We have received a final file named as directionFinal.txt. Now we move toward handbook extraction part. But there's a little twist. Here before we were scraping data from URL, but for handbook we have downloaded the file named content in our system, consisting of all markdown files from which we will be extracting all the information. Now the very first script in the GitLab handbook is extract GitLab handbook structure.py. The script starts with importing OS and path for file and directory management and operation. Then we have RE module here for cleaning out the unwanted and messy data. Now here we have defined a handbook directory which essentially points to the content folder which we have downloaded in our system. Then we have specified a directory path which is output file where we'll be saving the output of this script, which is handbookclean.txt. Now we have a function which is using regular expression, which is the RE module which we imported here. This is to clean the data which we will be extracting from the content folder present here. Now we have getLogicalPath function which essentially works on getting the exact right path from the directories and making sure that it doesn't break. Now here we have a function named as extract all handbook We are basically extracting all the data from the content folder here in the system, and then we are calling our clean markdown function for the code we have written here. And after all the cleaning and processing of the data, we are essentially saving the final output file on the output file location, which is essentially here as handbook clean.txt. Now with that, our data acquisition part of GitLab handbook is completed. Now we have another Python script named as com.py. Here we are essentially comparing those two files. First is the downloaded raw handbook clean full.txt with freshly extracted handbook clean.txt. And now if I run this program, I basically get something like this as output, which shows the basic stat, the total line present in this file with their relative words, as well as in this one with the section header comparison and the paragraph level comparison. And at the end of the day, we get a cosine similarity between them. Now with that, our both data acquisition parts are covered with direction and handbook extracted into this clean and final outputs. Now our main part is creating this FAISS index, which is basically the vector database, and we do that by build-vector-store.py. It is one of the most important file in the part 1, which carries out one of the most significant operation, which is creating of index.FAISS and index.pkl. These are the vector store, and these are essentially gonna power our RAG chatbot for semantic search. Now let's take a look at the code. From LangChain.TextSplitter, we are importing recursive character text splitter. It is going to split our knowledge base into small manageable chunks. And now from LangChain Hugging Face, we are importing Hugging Face embedding. From this, we will be using an embedding model, which will later embed those chunks into vector numerical data. Now from LangChain community, we are importing FAISS. This is essentially gonna create a vector file, and path is for path operations. Now we load the direction final.txt and handbook clean.txt in variables. Now we initialize the text splitter by using the same module which we imported at the very first, with the chunk size of 750 word and overlap of 150 word. Now after that, we have a function chunk with metadata. This will essentially create the chunks with the metadata attached to it for the overall better context. Now after the creation of the chunks, when we call this function, it will create the chunks in those respective variables of those respective files, and then we will merge them in all docs. Now we will initialize the embedding model, which we are using here is all mini lm l6 v2, and then at the end of day we'll create the FAISS index, and we'll save it locally at this direction part, which will be located around here. That was all there in the part 1 to offer. There are a few more things you'll want to take a look at in the file structure of part 1. The documentation is like a vast knowledge vault of various aspects of these projects and should be considered whether you need an extra insight. The flowchart and system design consist of all graphical charts demonstrating the workflow and system design of project made in Mermaid. The collab folder consists of an IPYNB and its component, with an additional how to run instruction PDF which offers step-by-step explanation on how to execute. The code snippet explanation has every line of code explained inside of it. And at the end, the readme.md has an overall file structure highlighted and explained in details. The second part of this project primarily focuses on phase 2, retrieval and generation. In the first part, we successfully created our vector store, which now serves as the context box for retrieving relevant information. In this phase, we will use that vector store to power our RAG chatbot, allowing it to answer user queries in a terminal-based chat conversation. But before we dive into the actual code, let's take an overall look at the file structure of part 2. A IPYNB file dedicated to part 2. Then there is a code snippet explanation explaining each line of the code to make sure that each and every component and operation of this code is clearly understood. Then a readme file gives a comprehensive overview of this project's file structure and detailed information. The env file is something new. We did not have this in part 1 where we didn't require any secret key, but here you will need to paste your API key. The API keys are private, make sure you not share that with anyone. Now with that context in mind, we can move on to the main file, which is llmintegration.py, and start walking through the code step by step to understand how the retrieval and generation components work together to power the RAG chatbot. Please paste your API key here. Remember, it won't be visible since they are private, and press enter so it accepts the API key, and please wait while it loads. Now your chatbot has been loaded. You can ask it wherever a question you want. And it sure does answer, and eventually you type quit to exit. Now let's take a look at the part 3. Part 3 majorly focuses on development and deployment of the RAG bot's frontend. The frontend is built into the Streamlit. The main Python file is streamlit.py. Let's have a look at it. At the beginning, we make sure our script can access the module from part 2, specifically the function that handles API key setup and QA chain building, which we have imported here from the part 2 LLM integration, which we wrote earlier. We also import Streamlit, which will be powering our front end and managing the interaction on web interface. We set up the Streamlit configuration. Later, we move towards setting up the API key. The app checks for the Gemini API key in Streamlit secret, which is basically streamlit.toml file present in our system. Here, you have to paste your API key in order for the streamlit.py to work. If the API key is present, it is used to set up the LLM. If not, the app shows an error to stop the execution, promoting the user to add the key. Now, we are loading the build QA chain, which this is the setup of the Streamlit UI. This is basically the title and the markdown information which will appear on the web-based interface. Now here, we are basically using Streamlit session state to maintain the chat history across multiple user queries. This is basically to ensure that the past question and answer remain visible to the user, providing a seamless flow of conversation. Now, we have basically written a code for handling the user queries. Whenever a user submits a question, the input is displayed in the chat as a user message, and the QA chain generates a response from the RAG bot using the relevant context from vector data. Now, the chatbot answer is displayed in the interface. Additionally, we show an expandable section of the source and reasoning, listing which document section the answer was drawn from and the snippet of the content. This transparency helps user understand where the information came from. And at the end, if something goes wrong while generating the answer, the app displays an error message with exception details. Now, let us go through and run this program to see how the user interface look like. Now, to run this, I want you guys to install the requirement.txt, as these are the necessary dependencies you'll need to run the Streamlit UI. If installing this doesn't work for you, just go ahead and install requirement2.txt. If you're wondering what is the command for installing the requirement.txt, then it is pip install. It is pip install -r requirement.txt. I already have all of them installed, so it is saying requirement already satisfied in mine, but it might take a little time in yours. Now, go ahead, open the secret.toml and paste your API key which you generated in part 2 here, so it can power our front end. In case if you're wondering how to get a Gemini API key, then simply head over to aistudioGoogle.com, click on create API key, click on Gemini API and create an API key. I already have mine one created, so I'll just copy this from here and then paste it in this file. Now, to run the Streamlit UI, you have to type Streamlit run and then copy the relative path of this and simply click enter. This will open your Streamlit UI on the local host. Now you can start having a conversation with your RAG chatbot in your front end. You can further go and even deploy it. For deployment, you will need to push this whole GitLab RAG chatbot into a repository of GitHub, and then you'll simply be able to deploy it using the Streamlit Community Cloud. Here, as you can see, it answers and as well as shows the additional source and reasoning. Alright, that's all for this video, and I hope it covered most of the things. And if anything is missed in this video, you'll find the documentation section which has everything in detail, as well as every part covers a code snippet explanation. So please go through that, and best of luck.